Hey everyone, welcome to episode 14 of our Neet Chemistry series for 2025 and 2026 series. I'm Chongtham David, your mentor, and with just 17 days left for Neet, it is time to log in your fundamentals. Today, we're exploring one of the most powerful tools in chemistry, the periodic classification of elements. This episode will walk you through 45 well crafted questions that will sharpen your grip on trains, blocks, periodicity, and predictive chemistry. Exactly what the need loves to test. And here's something to reflect on like the periodic table brings order to elements, discipline brings clarity to your preparation. Master the trains, and you'll master the questions. Let's connect the elements, crack the logic, and climb one step closer to your neat goal. Now, without any further ado, let us move on to this question. I'm going to start sharing the screen. Question number one. It's an easy question. Which of the following is not an actinoid? Before we begin answering this question, I would like to give a tip. Learn by heart the elements in the modern periodic table as much as possible. That will give you edge in the exam. Now let's read the question. Which of the following is not an actinoid? Terbium is the answer. Let's read question number two. This is a lanthanide. Okay. Question number two. I hope it's clear. Which of the following species has lowest oxidation ionization potential? Oxygen atom, oxygen molecule, oxygen cation, and anion. And see the additional pi molecular electron in O2 minus is added to the less stable antibonding orbital. Hence, it is easy to remove that electron from O2 minus ion. Thus, this ionization enthalpy or ionization potential of O2 minus would be the lowest. So D would be the answer to question number two. Question number three. On going down a main subgroup in the periodic table, example lithium to cesium, in group 1A, beryllium to radium in 2A, the expected train of changes in the atomic radius is a continuous increase, decrease, periodic one, and increase followed by a decrease, and decrease followed by increase. So continuous increase as number of cells increases down the group. So A would be the answer for question number three. Continuous increase. Okay, moving on to the next question. Question number four. Let us read together. This is a match the column type, and option D is not visible. V, D, and E. So let us bring up those options uh, in column A and column B, and we shall write it together because the screen is not seen. So whatever that is on the first side of the screen, let me write it here. A, B, C. Okay, this is for your reference. BF4 minus. In B you have aluminum hexafluoride ion. In C you have oxy difluoride. And 1, 2, 3, the oxidation states. And the coordination number is 7. Oxidation state is plus 7. 4 plus 7. 4 plus 4. 6 plus 3. So you are required to match the column for this question. So if we analyze properly, this BF4 minus would match best with coordination number 4. Okay, because you have 4 fluorine here. And you can find the oxidation state of this boron. X plus 4 into minus 1 equals minus 1. So X would be plus 3. So in the same train, you have to find out for the remaining as well. So B, you have to match with 3 because coordination number 6, oxidation state would be 3. And C would be best match with 4, coordination number 2, oxidation state plus 2. D would be 2, I of 7, oxidation state. So A5, B3, C4, D2, E1. B would be the answer for this question number 4. Let us move on to question number 5. The decreasing order of the ionization potential of the following elements is. So neon, chlorine, phosphorus, sulfur, these are all the given elements. You have to arrange in the decreasing order of the ionization potential. So closed cell neon have, and this half filled phosphorus, and this completely filled magnesium. These are the ones which has, these are the reasons for the higher value of ionization enthalpy. So the first one would be neon definitely because it has closed and phosphorus has half filled. So when you do the arrangement, chlorine will, neon will be the first, chlorine followed by phosphorus, sulfur, magnesium, then aluminium. So this would be the answer for question number 5. Question number 6. The radii of fluorine atom, fluoride ion, oxygen atom, O2 minus are in the order. So according to Fajan's rule, O2 minus has higher value of atomic radii than fluorine. Oxygen, these are atoms, okay? If it is cation, the size would shrink. So B would be the answer to question number 6. Question number 7. Which group of the periodic table contains coinage metal? In the ancient days, currency coins are made from copper, silver, and gold. So this copper, silver, and gold are referred as coinage metals. They belong to group 1b, the D block of the modern periodic table. So this is based on the Mendeleev's classification. B, 1b is the answer. Alright, question number 8 is quite lengthy. Let us read slowly. Which of the following statements are correct? The second period starts with lithium and third electron enters the 2s orbital. The next element, beryllium, has 4 electrons and has the electronic configuration of 1s2, 2s2 from the next element, boron. The 2p orbitals are filled with electrons when the L cell is completed. At neon, thus there are 8 elements in the second period. So you have to find which is the correct answer. This, okay. So 1, this would be the correct statement. Next, let us read the second statement. Successive filling of 3s and 3p orbital give rise to the third period of 8 elements from sodium to argon. This is also correct. What about statement number 3? The fourth period starts with potassium and electrons are added, fill up the first 4s and 4p orbitals, then 3d. No, this is not the correct sequence because it violates the above principle. So 3 would not be the answer. Fifth period begins with rubidium with the filling of 5s orbitals and ends at xenon with the filling up of the 5p. So this would be the correct answer. So if statement 1, statement 2, and statement number 4 are the correct statements for this question number 8. The correct answer would be 1, 2, and 4 would be option D. So D is the answer to question number 8. I hope it is clear. Let's read question number 9. Which ionization potential of the following equations involves the greatest amount of energy? Sodium is undergoing oxidation simultaneously for potassium ion, calcium ion, calcium and carbon ion. So for this sequence of oxidation, this potassium ion already in 18 configuration. Okay, so if you have to remove electron from noble gas, it will be very tough. So this is isoelectronic with your argon. So removal of electron from 18 system is not that easy, right? So it will be very high in ionization potential. So option B, question number 9, this is the answer. Moving on to question number 10, which of the following arrangements represents the increasing order of ionic radii of the given species? O2 minus, S2 minus, N3 minus, P3 minus. See, these are isoelectronic species. They have the same. Are the isoelectronic species? We have to first check. For isoelectronic species, this ionic radii will decrease as the charge on the ion increases, as determined from the Fajan's rule. And further on, moving down the group, ion radii increases. So hence the order would be O2 minus, followed by N3 minus, then S2 minus, and P3 minus. So option A would be the answer for question number 10. Let us see question number 11. Which of the following series correctly represents the relation between the elements from X to Y? Okay, so on moving down the group, the atomic radii is bound to increase. So these are the elements of group 14: carbon, silicon, germanium, tin, lead. Right? As usual in the classroom, I always explain by giving mnemonics: carbon, silicon, germanium, tin, lead. How to remember this group 14 elements? Chemistry sir gave some problems. In that way, you can remember the entire modern periodic table. So which of the following series correctly represents the relation between the elements from X to Y? So C is the correct answer. Argon to general noble character increases. This is not the correct answer. Let us see question number 12. The formation of the oxide ion from oxygen atom requires first an exothermic and then an endothermic step as shown below. So this incoming electrons, they will occupy the smaller 2 and n equals to 2 principal quantum number, and this negative charge on this oxide ion is another factor due to which this incoming electron feels the repulsion. So what happens? The electron repulsion outweighs the stability gained by achieving the noble gas configuration. So A would be the answer for question number 12. I will show you the remaining options. Oxygen is more electronic, this is wrong. Then addition of electron in oxygen results in the larger size of the ion. This would also be incorrect. So A would be the right answer for question number 12. Let us move on to question number 13. Question number 13 says, in any period, the valency of an element with respect to oxygen, so increase by 1 from group 1A to group 7A, decrease by 1 from 1A to 7A, this is wrong. Increase 1 by 1 from 1A to 4A, and then decrease from 5A to 7A 1 by 1. So this is the answer for question number 13. This is the regard with respect to valency. Let's read question number 14. An element having electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. It forms. What is this element? 3s2, 3p6, 4s1 means Is it not potassium? And it is alkali element. It is electronic configuration of potassium. Potassium belongs to group 1A of the modern periodic table, and hence this will be very metallic in character. And when metal form oxide, they are basic. So the answer would be option B, basic. I hope it is clear. Let's see question number 15. Which of the following order is wrong? The train goes on increasing down the group for acidic character. Is it correct? No, the basic character is increasing, bound to increase. Should be basic. This is wrong. And what about option B? Lithium, beryllium, boron, carbon. Yes, the first ionization enthalpy increases. This is correct. No, this would also be wrong. Question is asking determine the incorrect statement. Which of the following is wrong? Okay, not the correct answer. So ammonia, phosphorus, arsenic. Okay, acidic correct. It should be correct because the ability to release hydrogen would increase. A is the correct option, but we have to figure out the wrong answer. Lithium, beryllium, boron, carbon. Why this is not correct? It is because of the configuration. Beryllium has high symmetrical configuration as contradictory to boron and carbon. So the sequencing would be lithium, boron, and so on forth. So this is not the correct statement, but this should be the answer for question number 15. Let us check anyway for C. The basic character increases. This is also correct. Lithium, sodium, the size keeps on increasing down the group. So which of the following order is not correct? Is wrong. So B, the right sequence for this particular question would be lithium. It should be boron, okay? Because boron has more stable configuration than carbon. So beryllium would be higher in ionization potential than boron because beryllium has completely failed S configuration. So this particular sequencing is not correct. So 15, correct answer would be B. Let's read question number 16. The first ionization and potential of aluminum is smaller than magnesium because aluminum it has 3s2 P1 and magnesium it has 3s2 configuration. Lower the energy and lower energy is required to remove the 3p1 electron than the 3s1 electron. So the penetrating effect sequencing is S, P, D, and F. And secondly, magnesium has stable electronic configuration than aluminum. So C would be the answer for question 16. 17. The first ionization enthalpy and the second ionization enthalpies and the electron gain enthalpy of the elements 1, 2, 3, 4, 5 are given. The most reactive and the least reactive non-metals of these are respectively. So this 1 represents lithium, 2 represents potassium, 3 represents bromine, 4 represents this iodine, and 5 represents helium. So among these, 2 represent most reactive metal and this 5 represents the least reactive non-metal. 17 would be this 2 and 5. So this would be option C. I hope it is clear. Let's see question number 18. Consider the following statements. The discovery of inert gases later on did not disturb the Mendeleev's arrangement. In the present periodic table, periodicity in the properties of element is regarded to the periodicity in their electronic configuration. We have to find the correct statement for this question. So both are correct. So option C would be the answer for question 18. Moving on to question number 19. Quite lengthy again. Consider the following ionization potential or enthalpies of two elements A and B, first, second, and third. Which of the following statement is correct? Both A and B belong to group 1, where B comes below A. And here it says both belongs in group 1 and A comes below B. In the second case, both belongs to group 2, where B comes below A, both belongs to group 2 where A comes below B. So generally the ionization enthalpies or this energy increases from left to right in a period and decreases from top to bottom. So several factors such as your atomic radii, nuclear charge, shielding effect are responsible for the change of this ionization enthalpies. Here the first ionization enthalpy of A and B is greater than group 1, that is lithium. We have given here 520 kilojoule per mole to cesium, which is about 374 kilojoule per mole. This suggests that this element A and B belongs to group 2, and all the three given ionization enthalpy values are less for element B, meaning B will come below A. Right? So 19, the answer would be option C. I hope it is understood. Let's read again question number 20. Sodium sulfate is soluble in water, whereas barium sulfate is sparingly soluble because, see, for dissolution process, the hydration energy, keep this in mind, for dissolution process, your hydration enthalpy or energy should always be greater than your lattice energy. Otherwise, your dissolution process will not be effective. Barium sulfate is sparingly soluble in water because its hydration energy is lesser than the lattice energy, and thus the ions are not separated from each other. So the lattice energy of barium sulfate is more than its hydration energy. Okay, you can refer to here to this point why this is sparingly soluble, and you can give the answer from this key that I have given here. Hydration energy is greater than lattice energy. So these are the key concepts you have to keep in mind. B would be the answer for question 20. Moving on to question number 21. Which of the following is the reason for the different chemical behavior of the first member of a group of elements in the S and P block compared to that of the subsequent members in the same group? So this anomalous behavior of the first member of group is in the S block and in the P block is mainly due to their small size, large charge ratio, radius ratio, and high electronegativity. You can also give high ionization enthalpy because size is already small. Anyway, 21, the answer would be small size, large radius ratio. Should not be low electronegativity. So 1 and 2 is the only answer. 3 will not be there. Moving on to question number 22. The elements with outer electronic configuration 3d6 for S2 is. What is this element? So this 3d6 for S2. In this configuration, the differentiating electron enters the d subshell and hence it represents the transition metal. So the configuration would be 3d6 for S2 means it is atomic number 26. Your element is iron, right? So 22 answer would be a transition metal. Good. Let's move on to the next question number 23. Which of the following statement is wrong? Van der Waals radius of iodine is more than its covalent radius. All isoelectronic ions belong to the same period. Ionization enthalpy 1. First ionization enthalpy of nitrogen is higher than that of oxygen, while the second is higher than that of nitrogen, reverse. The electron gain enthalpy of nitrogen is almost zero, while that of phosphorus is 74.3. So in the isoelectronic species, all the isoelectronic ions belong to the same period and cations to the next period. So all the isoelectronic, this would be the answer B. This is not the correct statement. Question is asking, find the wrong statement. How can this be true, right? Question number 24. Which of the following sequence correctly represents the decreasing acidic character of oxides? A very basic question, easy. On passing from left to right in a period, acidic character of the normal oxide elements increases with the increase in electronegativity. So this is not the answer because lithium, beryllium, boron, this will not be the correct sequencing. What would be the correct answer? The options are not given here, incomplete. And you will suggest the correct sequencing. It would be in this train. N2O3 greater than carbon dioxide, then boron. You keep in mind metal forms oxide, which is basic in character, non-metal forms oxide, and it will be acidic in character. So this would be the correct representation of the decreasing acidic nature of the oxides. Okay, let's read the next question. Question number 25. An atom has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 3, 4s2. You will place in which group? Okay. Is it in the fifth group, 15th group, or the third group? So how can you answer this question? The given electronic configuration, it suggests that it is a d block element, right? And it has the configuration n minus 1. The general electronic configuration of d block was n minus 1, d 1 to 10, ns 0 to 2. So in the penultimate orbital, this 3 electron enters, and it starts from 3b and goes up to 2b. So this D3 configuration will be classified in the group. So it must be the fifth group. Okay. So you can also generalize in this way. For D block elements, just count the penultimate electrons and the valence electron. You have 3D3, right? 4s2. So you just count the penultimate D and the valences. This would add up to your group number. I hope this is clear. Let's read question number 26. In which of the following arrangement the sequence is not strictly according to the property written against it? You have oxidizing power, basic character, increasing acid strength, increasing first ionization enthalpy, right? So this correct order of increasing basic strength, this is wrong. It would be ammonia greater than phosphine greater than arsine than stibine. This would be the acidic strength. So reverse would be the basic strength. Question is saying not the correct sequence. So B would be the answer for question number 26. I hope this is clear. Let's read question number 27. Which one of the following statement is incorrect? The greater the nuclear charge, greater is the electron affinity. This is true, very true. Nitrogen has zero electron affinity. This is also true. Then electron affinity decreases from fluorine to iodine in this 17. This is wrong. Chlorine has the highest electron affinity, correct? So C would be the answer for this question 27. Let's read question number 28. An element X occurs in short period having configuration Ns2np1. The formula and nature of its oxide is. So this Ns2np1 is the electronic configuration of 3a period, and Al2O3 is amphoteric oxide. So answer would be C. All right. Let's read question number 20. Okay, 29. The ionic radii of the following, which is the correct answer. This pentavalent ion, I will write here phosphorus, P5 plus has more effective nuclear charge and smaller size as compared to P3 plus. So this would be the correct answer. Others are wrong. Okay. How can this be greater, right? These are isoelectronic species. Moving on to next question. The ionic radii in terms of angstrom of N3 minus, O2 minus, and F of minus are respectively. So you need not learn by heart all these values. Just go from the general concept and apply the rule here. So for isoelectronic species, size of the anion, that is negative charge ion, increase as the negative charge increases according to the Fajans rule. And the correct order is, it would be, these are all isoelectronic. It would be N3 minus, which would be greater than O2 minus, then greater than your fluoride. Now do the comparison with this sequencing. So this would be 1.7, 1.4, then this would be 1.36. So option A would be the answer. Because basis on this, you have to give the ranking, right? Anyway, question number 31. Amongst the hydrides of group 16, they are called chalcogens. Oxygen, sulfur, selenium, tellurium, they form hydrides. The one with the highest boiling point is the hydrogen bonding increases the boiling point and hydrogen bonds. Remember, I will re-explain again. In the classes I used to write, I can't handle dirty events. Some of my students would be knowing this. I stands for ionic, C for covalent, H for hydrogen, D for dipole, and this stands for van der Waals. The mnemonic is I can't handle dirty events. Anyway, this hydrogen bonding has two types, inter and intramolecular hydrogen bonding. So hydrogen bonding increases the boiling point. Hydrogen bonds are formed in compounds having fluorine, oxygen, and nitrogen. We call it FON, right? So sulfur, selenium, tellurium cannot undergo hydrogen bond formation because of their large size and low electronegativity values. So option would be A. Let us see question 31. Match the column with elements in column 1 and elements in and the properties in column 2. So let us see and analyze. A would be lithium, aluminum, magnesium, potassium. This is ionic radii. And this sequencing, lithium from lithium to potassium would be, this would be the effective nuclear charge. Chlorine to iodine, this would be the electron affinity. And fluorine to, this would be electronegativity. So A2, B1, B4, C1, D3 is option B. Option B, son. Next question number 33. Which of the following statement is or are incorrect? 33. Aluminum react with HCl to form aluminium ion and hydrogen is liberated. This is correct. Aluminum dissolved, you have to go with SRP values. Aluminum dissolved in sodium hydroxide to form sodium methylmalate and hydrogen. This is also correct. So if both are correct, A is the answer to question number 33. Moving on to question 34. Which has a stable plus 2 oxidation state? The stable plus 2 oxidation state, lead, you know the configuration of lead, Pb2 plus, atomic number 82, 5d1, 6s2. So it has the most stable plus 2 oxidation state because here the d orbital is completely filled and is more stable than iron. You know the configuration is 3d6. Again for silver it has d10 configuration, silver ion, and it is more stable here. Again, the d orbital is completely filled and the silver 2 plus is not easily obtained. So Pb2 plus is more stable compared to tin 2 plus. The configuration of tin 2 plus is 4010 5s2 because of the large size. So more stable would be B, lead. Question 35. Okay, now what can we conclude here? Multiple choice type question would be likely be asked from this chapter, from periodic classification of elements. So Neet loves to test this type of question for periodic classification. Practice as much as possible. Now let us see the question. This is based on IUPAC name of atomic number greater than 100. So 35 question would be A. Anilhexium. This is your seborgium. Okay, as I have told you on the introductory part of this class that knowing the atomic number beyond 100 is going to be very vital for your exam because from 100 to 118, these are the important questions. Need loves to test. Question number 35b. Let us try to match. B would be aniltrium, would be it's lawrencium 103. Anilnium, C, atomic number would be it's mendelevium. Anilpanthium, 105, it will be dubnium. So A3B1C4D2 is option B. Okay. Moving on to question number 36. In the Mendeleev's periodic table, which of the following element instead of having lower atomic weight was placed after the element of higher atomic weight, thereby ignoring the order of increasing atomic weights? So iodine with lower atomic weight than that of the tellurium group 6 was placed in group 7 along with the fluorine, chlorine, bromine, iodine. Okay, so because of the similarities in the properties. So option A would be the answer for question number 36. I hope it's clear. Let's read question number 37. This is the van der Waal and covalent radii of fluorine atom, respectively from the figures it is shown. So which one is the correct combination? First, van der Waal and later covalent. So covalent radius is the radius of an atom in its bound state. That is, in fluorine, it is half of the distance between two covalently bounded fluorine atoms. Van der Waal radii is one half of the distance between the nuclei of two identical non-bonded isolated atoms. So these atoms are attracted toward each other through weak van der Waal forces. Hence, these van der Waals radii are very large. So what would be the option to this question number 37? Would be 147 and 70. You divide this into half each. You will be getting 147 and 72 as the answer. I hope it's clear. Let's read question number 38. Chlorine, bromine, iodine, if this is in the double Ernest stride, and the atomic masses of chlorine and iodine are 35.5 and 127 respectively, the atomic mass of bromine is. So question number 38, according to the Dobereiner stride, the atomic mass of bromine will be the average of the combination of atomic mass of chlorine and iodine, right? So 35.5 plus 127. So what will we be getting? You try to add 5.7 plus 5, 12, 326. 162 divided by 2 would be 81.25. So option C would be the answer to question number 38. This is based on the Dobryner's stride of classification of elements. During the time, only few elements were there. Question number 39. The first ionization enthalpy of sodium is 5.1 electron volt. The value of the electron gain enthalpy of sodium ion will be. So for sodium, the oxidation can be written as Na plus. After losing the valence electron, the first ionization enthalpy is given as 5.1 electron volt. So for this sodium ion, if it is undergoing a reduction in the reverse process, that will be the negative of this. This is the reverse. The value of the electron gain enthalpy would be minus 5.1 eV, right? So B would be the answer to question number 39. I hope it is clear and understood. Moving on to question number 40. As we move across the second period from carbon to fluorine, ionization enthalpy increases, but the train from carbon to fluorine for ionization enthalpy is carbon, oxygen, nitrogen, and fluorine. Why it is not carbon, nitrogen, oxygen, fluorine? This is the coefficient. This is mainly because this nitrogen has half-filled atomic orbital, which is more stable. So the electronic configuration of nitrogen is more stable than oxygen. This will be the answer to question number 40. Moving on to 41, the electron affinity of chlorine is 3.7 eV, and when 1 gram of this chlorine is completely converted to chloride ion in the gaseous state, the energy released in the process would be. So now let us do some calculation here to find the number of moles. Let us see. Number of moles can be calculated as 1 by 35.5, right? So given that 1 eV equals to 23.06. This is in terms of kilocalorie per mole. Now 3.7 eV would be how much? If this is based on unitary method, you simply multiply the value for 1 unit, then subsequently you will be getting the answer. That is 1 mole of energy release, this much amount of kilocalorie. So the required, let me write it in the below section because spaces is not there. So therefore, your energy release in the process would be 1 by 35.5 into 3.7 multiplied with your given EV 3.06. Calculate this and you will be getting the answer. So roughly you can cancel 1 by 1 to 1.111, 1123. So 11 twos are 22. So roughly 2.4. You need not calculate the exact value in the exam. Just go with the approximate value. That saves your time. Let's see question number 41. Gradual addition of electronic cells in the noble gas causes a decrease in their decrease in their ionization energy. Okay. Moving on to next question. 43. The formation of the oxide ion requires first an exothermic and then an endothermic step. So gaining electrons, this is exothermic. Losing, okay, second subsequent addition is negative. Because in the negative environment, if you add again, it repels. This is the key. So what happens to this system? This O minus exerts a force of repulsion on the incoming electron. Thus, the extra energy is required to overcome, and hence it shows this type of train, that is endothermic process. 43 would be O minus will tend to resist the addition of another electron because minus and minus repel. So 44, the last question, which of the following is correct about Eka aluminum and Eka silicon? These are oxides. See, oxides of Eka aluminum. What is Eka aluminum? It is gallium oxide. The formula of gallium oxide is Ga2O3. You know, gallium, one interesting fact is that when you put in your palm, it melts because its melting point is very low. It melts at 27, and our human body is having a temperature of 37 degree. Anyway, this gallium oxide, it is your oxides of Eka aluminum, and oxides of Eka silicon is silicon dioxide. So melting point of Eka aluminum is low, around 302 in terms of Kelvin, 302, and in terms of Eka silicon, it has a very high melting point, that is 1231. So both A and C would be the correct answer. So option D is the answer to question number 44. I hope it is clear and understood. And as usual, you take the screenshot of this last question, question number 45, read and try to answer the question and give in the comment section. Thank you for joining up to this. We shall meet in the next class. Happy learning.